Welcome to this video tutorial on the zero exponent and negative exponent properties in Algebra 1. The way we're going to go about showing these is we're first going to kind of show where they come from, give you an idea of how you can use patterns to discover these. If you look at 2 to the third, 2 to the third is 8. We know that, we've already talked about that. 2 to the second is 4, 2 to the first is 1, or is 2. And so you have this pattern that's developed as we go down in one in each exponent, 2 to the third, 2 to the second, 2 to the first, we're actually dividing by 2 each time. And so to explore this, it only makes sense if we divide the next one by 2, we get to the 1. So 2 to the 0, drop your exponent by 1, would equal 1. You can look at the same thing from the 3s. 3 to the third is 27. 3 to the second is 9. 3 to the first is 3. So when we're doing these, again, you're dropping each exponent by 1, subtracting 1 from the exponent, and you're dividing the answers by 3. So when we divide 3 by 3, we get 1, and we go down 1 in the exponent, we get 0. So it shows again that 3 to the 0 equals 1, looking at these patterns. And you can do this for any number. You can do this for 4, you can do this for 5, you can do this for 6, you can do it for 7. It's just going to keep going on, and every time you're going to get down, you're going to have 2 to the 0 equals 1, 3 to the 0 equals 1, 4 to the 0 equals 1, and so on. And that's always going to be the case. And that leads us to the zero exponent property, or the zero property of exponents, I guess maybe would be a better way to say it, but we've written it here as a zero exponent property. And essentially what it says is that anytime you raise a number or a quantity, it's probably best to say quantity. I'm writing that there because it doesn't just apply to one number. It can be a few numbers multiplied together or whatever. But any quantity raised to the 0 power is always equal to 1. So no matter what value we put on there, it's going to equal 1. We can write it out using symbols if we want. And just show that any value m raised to the 0 power equals 1, no matter what. And it becomes a very powerful property that we'll use a lot. You can write a long number out, 3,132 to the 0, that also equals 1. So it doesn't matter what value that is or how big it is, 3 to the 0 always equals 1. So that's the zero property. The negative exponent property, we're going to explore the exact same way. We'll start with 2 to the third equals 8. 2 to the second equals 4, 2 to the first equals 2. We now know 2 to the 0 equals 1. You're just dividing by 2 each time. So now, when we do our next one, if we drop one power to 2 to the negative 1, and then divide 1 by 2, you get 1/2. So 2 to the negative 1 equals 1/2. 2 to the negative 2, well, 1/2 divided by 2 is like multiplying 1/2 times 1/2 is 1/4. 2 to the negative 3, well, 2 to the negative 3, divide 1/4 by 2, you get 1/8. Now we look at the pattern, and we're going to look, let's go look at the 3's and just do the same thing so we can see this pattern twice. We already know 3 to the third is 27, and 3 to the second is 9, and 3 to the first is 3, and 3 to the 0 is 1. Those are what we did on that last slide. Now we can look at 3 to the negative 1. Well, 1 divided by 3 is just 1/3. Now 3 to the negative 2, well, divide by 3 again. 1/3 divided by 3 is 1/9. And 3 to the negative 3, well, 1/9 divided by 3 is 1/27. So if you look at the pattern, you can kind of group things together. And so we can first start looking at the 2's and group the 2 to the first and 2 to the negative first together. And then you can look at the 2 to the second and kind of group it with 2 to the negative second. And then you can look at 2 to the third and group it with 2 to the negative third. And if you notice, the only difference is on 2 to the third it's 8, 2 to the negative third is the same thing except 1/8. And the same thing was 2 to the second and 2 to the first. 1 over whatever the positive power is. And then look at the 3's, the same thing's the case. 3 to the first is 3, 3 to the negative first is 1/3. 3 to the second is 9, 3 to the negative second is 1/9. 3 to the third is 27, 3 to the negative third is 1/27. And so if we want to write out our negative exponent property, we're going to consider that as how we do it. And this would continue to go on if you did 2 to the fourth and 2 to the negative fourth and 2 to the fifth and 2 to the negative fifth. And essentially what it is, the negative exponent property, we're going to write out as a symbols. A to a negative power, okay, is always equal to 1 over a to that power. So the way we can write it is a to the negative n is equal to the reciprocal of a to the n. That's what it always is. And if you remember, reciprocal is just 1 over. So if we write it out in symbols, it's a to the negative n equals 1 over a to the n. So 2 to the third, or 2 to the negative third, is just equal to 1 over 2 to the third. Right, which is what we showed over there on our chart, which is 1/8. So we can show doing it either way. So you just remember that that's always the case. A to the negative n is equal to 1 over a to the n.